What? Why doesn't it work? There it is. How will I know who I am if I don't have that there? Okay. Well, hi, everyone. My name is Fraser Cain. I am the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, November 22nd, 2013. Joining me this week, we've got Amy Shira Teitel from Vintage Space. Hey, Amy.
Hello.
We've got David Dickinson, a.k.a.
Hey,
the
hey.
Astro Guys, the cloudy astronomer. Oh, we're going to get into that in a second.
Yes,
Oh. And Nancy Atkinson from Universe Today.
Hi, everybody.
Hey, Nancy. So this week, let me bring this list over here. We've got 5 active comets visible with binoculars in the night sky, actually the morning sky.
Yes.
Halting nuclear engines. We've got a zillion launches, and I mean that specifically. 1 zillion satellites have just been launched. We've got Inspiration Mars update. High-energy jet from the black hole, 15 years of the International Space Station, possible NASA cuts, and problem of curiosity. So let's get rolling. I think let's start specifically with all of those launches. The biggest one here is MAVEN. So Amy, why don't you talk about the MAVEN launch, and then I know David has a whole bunch more as well.
Yeah, well, I'm sure. I mean, David and I were both at LASP in Boulder, Colorado this summer at the meeting all the science teams. So, David, feel free to jump in because.
Were you at the launch this week, Amy?
No, I couldn't get down. Knowing the uncertainty of launch windows, I couldn't.
There were thousands of people there, so
Really?
we would have never run. I didn't see anybody from LASP there.
Really? I knew a couple people were going down, but no, I watched it. I remembered about 5 minutes before launch that it was happening, so I did get to NASA TV to watch it, and for a mission that has no visuals, they did a really great job of having sort of a sort of animation of what was happening during the whole launch phase. And it was, from what I heard, I don't know if anything has come up after, but it was a flawless launch. Everything seemed to happen pretty much on time. They started right at the opening of the launch window, which means that they are on track to get to Mars. I think September 22nd, 2014 is the estimated date that they're going to go into orbit. And it's a really cool mission, and I don't just say that because I spent time with part of the science team and think they're awesome. MAVEN is basically going to look at Mars's atmosphere and sort of reverse engineer what happened to the planet, why it sort of became this cold, dry, more or less atmosphereless world that we see. So I think my favorite analogy for this, oh there, we've got Fraser showing the launch here. My favorite analogy of what MAVEN is going to do is that if Mars is a pot of boiling water, MAVEN is effectively going to scoop up a little bit of the steam and try to figure out how much water was in the pot before it was boiling. That's kind of neat.
we had a low deck cloud deck as seen from the causeway, so unfortunately we saw the launch for about 20 seconds before it vanished into the clouds, but it was still kind of cool to see. Yeah. It's one of those launches like there it is, oh, it's gone.
Well, it popped off the launch pad pretty quickly.
Yeah.
I don't know.
Yeah, it did.
I'm sort of used to watching old Saturn V launches, so anything that's smaller than that just seems to just rocket right up, quite literally rocket right up. But
what's the launch vehicle?
It was Atlas V.
It was an Atlas V.
Yeah.
But with no external boosters, it's just a straight up.
No, it went a 401 configuration.
I actually thought it took a long time to get going, but that's kind of an Atlas V thing. I mean, I remember I was at the SDO launch and same thing. It just like, okay, are you going? You going? Yep, good.
Yeah, they're a little slower moving than the Falcon rockets. This the last launch I saw was a Falcon 9, and that went really quick. The small ones go really quick. Or like the Minotaur launch Tuesday night, that went really quick.
I haven't actually seen a video of that.
Yeah, that was.
Fraser, do you have that queued up to show?
What do you want to see?
The Minotaur launch?
There was a Minotaur launch Tuesday night.
Yeah,
there was a night launch at a Wallops. We've had a launch every day this week from somewhere in the world. There was a Minotaur launch with the CubeSats on Tuesday. The Chinese did an unannounced, but it was a classified launch. There was no video of it. They did a military launch Wednesday, and there was an ICBM launch with more CubeSats on Thursday from Russia, and there was a swarm launch this morning. I've had a hard time keeping up with all these, as a matter of fact.
Yeah,
so how many CubeSats is that in a week now?
I think we're at, Tuesday was 29 plus there was a larger sat on there, yeah. And the Dnipro launch from Dombrowski on Thursday was
32.
32. Yeah, I
Yep.
thought it was funny because they broke the record for the number of payloads Tuesday, then they broke it again on Thursday.
That's really funny because I wrote the article on Tuesday about the record of 29 satellites.
Yeah, it
So
only,
there was, what, 60 satellites launched in the last week?
Wow.
Yeah, it's on Space Track it's nuts to try to keep track of all these NORAD IDs. A lot of us sat trackers were always like trying to assign what ID goes to what payload, and it's just been nuts this week because the numbers have been hopping up so quick.
But these CubeSats are so small. I mean, some of these CubeSats are just like you could hold them in your hand.
Yeah,
They're just like this big.
Yeah, you're not going to track them with binoculars or naked eye. They're too tiny to see. But
Sorry, go ahead.
No.
Amy, please talk.
I was going to say that I mean, from looking at some of I looked through at the 29 that NASA launched, and a lot of them are sort of proof of concept or proof of technology, or just kind of testing a specific kind of fuel cell, how it handles being in sort of an exposed solar environment. So yeah, it's not surprising that you could get so many of them on a launch vehicle, but they're so small because they're all these tiny little like individual test beds. So it's unclear.
One of them was done by a high school group. The one that was on the Minotaur launch was the first ever high school built and launched satellite. Well, they hitched a ride on the Minotaur, but it was totally built and conceived by a high school group. That was kind of cool.
These CubeSats, this is a great innovation in satellite technology because the price of these CubeSats to develop them is very low. I mean, it's a lot of it's off-the-shelf type stuff. A lot of universities and research groups can build these things. As you said, high school students, university students are able to build these things.
They're using these phone sats. They're the same Android operating technology that we have on our cell phones, so that a lot of us have.
Yeah, and so in many cases you want some kind of space-hardened gear, memory modules, processors, cameras and stuff that's a little more hardened for space, but it's not that bad. And so then the big price is, of course, the launch technology, the price of the launch. But in this case, they're launching these things on old ICBMs, or they're just grouping them all up to 29 at the same time, right?
Those Dnipro rocket launches out of Domborovsky Air Base are kind of cool to watch because they are ICBMs, and they literally, it looks like a Jack-in-the-Box launch when they come up because they're coming out of the ground silos. So those are kind of nifty. I wish it was like 1 a.m. in the morning here, so I didn't stay up to watch it. But they're kind of nifty to watch.
That is the best use of old nuclear missiles, because every one of those, you're watching a sword get hammered into a plowshare right there.
The Minotaur 5 that went out of Wallops with Laddie, those are old ICBMs too. That's what they're just repurposed.
Yeah, so the Minotaurs and the Russian versions of this is great. Just keep them coming. Just more. Every one of those is one less nuclear missile that could kill us all. I think it's fantastic.
Less war, more space exploration.
I think it was Carl Sagan that said space is the best use of nukes that he could think of. It was something along that line.
Well, I was doing an interview, and this will probably come out in the next couple of weeks. I was talking to Dr. Kevin Grazier, and he was saying that while asteroids are bad for hitting with nuclear missiles, in fact, either it'll just bounce right off. Comets actually are an effective target for nuclear missiles because
interesting.
Yeah, because you'll blow away all of the water.
To let Bruce Willis know that. So.
Yeah. So that might work.
To what end?
Just make it less bad if it's going to hit you.
Right.
Right. So shooting nukes at an asteroid, at a rock or metal asteroid, is a total waste of time. But shooting at a comet might actually be effective. Yeah.
Oh yeah. Okay, that makes sense.
But speaking of comets, there are 5 visible comets in the morning sky right now, right?
Yeah, there are 5 comets that are binoculars. They're in binocular range. I consider binocular range 10th magnitude, positive 10th magnitude or brighter. And we had 4 because, of course, we're tracking ISON right now. We had R1 Lovejoy, which is very well placed right now for observation. I've seen that one. That's about 8th magnitude. I think it's actually around 6th magnitude right now. X1 Linear brightened up recently. We had Comet Enki until we lost it in the morning early dawn. And now we have Comet C2013 V3 Nevski. This was just discovered earlier this month. And if that name sounds familiar, Ivan Nevsky is one part of the team that discovered ISON last year, along with Novichok was the name of the other Russian astronomer that discovered Comet Ison last year. Now this comet was about 14th magnitude when they discovered it earlier this month, which really it wasn't scheduled to be anything interesting until it brightened up about 250 times this early last weekend. Now it's in the 8.8 magnitude range is what I'm seeing from other observers. I have not got to see this one myself because I've been clouded out all week, but it's in the constellation Leo right now, so we're actually getting quite a little train of comets. I'm seeing a lot of good photos of R1 Lovejoy. We're seeing good photos of Ison until it's starting to get into that sunlight, twilight region in the early dawn sky where you're not really being able to see it right now. But yeah, I'm hoping for a clear morning here sometime this weekend. I have my alarm set for 5 a.m. every morning. My MO is I get up, I look out, see if it's clear, and if it's not clear, I go back to bed for an hour, and if it's clear, I get up and start observing. So I've been getting more sleep, but I really would I would prefer to be observing comets than sleeping, actually. So.
Yeah, it's been clear and cold here, but I haven't done any observing yet. So.
Yeah, and these comets are just starting to enter the range of, I know the stereo spacecraft are starting to image Enki and Ison, and next week they're going to start getting in the range of SOHO spacecraft and their LASCO C3 camera, and SDO will probably be where we're all going to be next Thursday on Thanksgiving after Turkey. We'll all be there watching to see. The big story is if Ison survives perihelion or not. So
it's the 28th, right? We're only now
yes,
a week away.
We're within a week right now, so it's going to enter into field of view of SOHO and then SDO, and that's probably going to be our key eyeball right there. There was a mission out of White Sands, I forget the name of it now, Fortis, that's the name of it, that was supposed to observe Ison this week. I've been kind of watching to see if there's any updates on that. It was a suborbital launch that was supposed to watch Ison for, like, do a 6-minute observation with the suborbital. I'm amazed the suborbital rocket can even aim and point to observe anything, but that's kind of cool they can do that. So I haven't heard any information out of that, but that may give us some more updates on what Ison is doing right now.
Now, I had seen some images that people thought that maybe Ison was starting to break up a bit and flare. What do you?
I keep hearing that, but I haven't heard anything really substantial. I keep hearing stories about Ison breaking up. This would be a bad time for it. If it broke up now, we may lose it after perihelion. And it's interesting, a lot of magazines that have a lot of lead time, like Astronomy and Sky and Telescope, they've already written and published their December and January even issues are on the newsstand, so they have to really be speculative as far as what they think Ison's going to do, because they already have all their stuff out there on the newsstand right now saying, you know, whether Ison is great or Ison fizzled or whatever. So.
Well, as you remember, we did a special, we participated in this Discovery Channel special about 3 weeks ago, and same kind of thing, like they're putting a lot of energy and effort and hope into Ison brightening, becoming the comet of the century that we're expecting. And
you know, a breakup right around perihelion might be interesting, though. If it did it right around perihelion, we could end up kind of like the Comet Lovejoy, W3 Lovejoy a few years ago, where you have that headless comet kind of heading out, or a string of comets heading out, and that would be cool too.
Yeah, now, earlier this.
Oh, go ahead, Nancy.
Earlier this week, one of the Max Planck observatories put out an image that they took, and they said that it kind of had sprouted wings and that kind of thing. But I was kind of keeping track on things on the Comet user group, and a lot of people were saying, "Oh, we're not seeing that," and so I kind of held off publishing on that because there was a lot of people saying that they weren't seeing that. But I did see a picture from Joseph Brimacombe. I think he put it out yesterday, and there was like a kind of a shooter or just a piece that was separate, so you know, maybe he did capture a piece that maybe was coming off there. I
followed that same Yahoo group. Yeah, it's a pretty good group of pretty knowledgeable people. Right. One thing I wanted to mention, because and I kind of headed it off because I knew it was going to become an issue when I wrote this post on 5 Comets, but it's already out there around the internet, is none of these comets are related. They're all on different orbits. Because the first thing people always ask me is like, well, are we suddenly seeing a lot of, is there like a comet storm heading into the inner solar system, or are these comets heading to us? Enki has been well known for over a century. Ison we've known about for a year. Lovejoy is on a 7,000-year orbit. This current one, Nevski, is a very tiny comet, and it's on a Halley-type orbit, I think 30 years, I believe it is. But these are all on, and we've had years, remember when we had Hale-Bopp and Hyakutake, when those came by, those were like within 6 months.
Here's Joseph's picture, by the way.
Oh, wow.
Nice.
Yeah.
And back in 1910, we had the Great Comet of 1910 and Halley's Comet come by within very quick succession. So it's kind of just a coincidence right now that we're having this lineup of morning comets that seem to be in the same direction, but they're on drastically different orbits.
That's great.
So
That's really going to settle down the conspiracy people.
I was just going to say, so this isn't the clear evidence of the world ending that we've all been waiting for.
Yeah.
Yeah. Okay, all right, well, let's move on. So now I would like to talk about the fact that the International Space Station's been around for 15 years, Nancy.
Yeah, 15 years, kind of a big milestone there. Yeah, so 15 years ago this week, the Russians launched the Zarya module, and then just a couple weeks later, then the U.S. launched up their first node, so they hooked the two pieces together, and they actually had Bob Cabana from NASA and Sergei Krikalev from the Russian Space Agency go in together. So it was kind of a symbolic thing. But yeah, so 15 years, and we've had, so that was in 1998, and then just 2 years later, in 2000, is when the first expedition crew went up there, and so since that time we've had continuous human presence up there, which is pretty impressive, actually. So yeah, that's almost 13 years that we've had continuous human presence in space.
And so when I started Universe Today and started reporting on the space station, like I started it in 1999, in March of 1999, and it had been up for 3-4 months. And so when I was first reporting on the space station, it was just the two modules together, and then as we reported on every piece from that point on.
Yeah.
It's amazing to think 13 years ago what we were doing, even technology-wise, and the internet was just kind of a baby then. So.
Yeah, and what's kind of cool to think about is just how little problems they've had. You know, all the pieces that have been built from different contractors around the world have all fit together perfectly, and you know, they've had some minor problems, like there was an issue with the solar array, and they got that fixed, and they're at the what are they called? The SARG, the things that actually turns the solar arrays, and they figured out how they could work around the problem with that. I mean, they've had some computer issues and some fire alarms that go off, you know, by themselves without any issues. So, you know, I think 13 years of hardly any or 15 years of hardly any problems is pretty remarkable, especially for you know, an international consortium like that. It's I think it's remarkable.
Not a colossally expensive boondoggle?
No, and now, I mean, so I wrote an article probably 3, 4, 5 years ago explaining why I loved the International Space Station. It was I Heart the ISS, and I'm working on a new one now, because one of my points in that article a few years ago was that you know, it's set for science. We're getting ready to have some science coming out of the station, and now we've actually got a lot of science coming out. And so my new article is going to focus on you know, 10 scientific reasons to love the International Space Station, because they do have some really great medical findings, and of course there's the alpha magnetic spectrometer. That had some big release earlier this year, although there's some debate about that. But yeah, I think it's just it's ripe for more discoveries coming out of there.
They launched satellites by throwing them out the window.
Yeah, that too.
They did that this week again too. Yeah.
But yeah, no, I know, Nancy, you are shamelessly our biggest International Space Station fan, and you dig up her old article. There's one other thing, Nancy, which is that it's been 9 years since you've been writing articles for Universe Today.
Yeah, wow. Just on Sunday was the anniversary of the first article I wrote for Universe Today, which I couldn't believe that Fraser gave me this assignment. It was interviewing astronaut Jeffrey Hoffman. He was working on a new way to deal with radiation in space and how to protect spacecraft. And they had this idea for a superconducting magnet to create a kind of a bubble around the spacecraft. Ultimately, their research didn't pan out, but it was really interesting, and I know it garnered a lot of discussion. So it was really fun, and I got to follow up with him later on. And yeah, it was great, and writing for Universe Today has been great, so I feel pretty lucky.
Yay! Me too. Aw, group hug, everybody. All right. Well, let's move on. Enough of this nostalgia. Let's talk about Dave. Let's talk about NASA halting their new nuclear engine. Come on.
Yeah, this was kind of troubling news. Came out this past weekend that they're going to shelve construction of their flight-ready, what's called ASRG, as Advanced Sterling Radio.
Do you need to do this again? Do you need to take a break?
No. Their plutonium-powered ASRGs are going flight-ready ASRGs are going to be shelved for now. They're still going to do the research and development over to the. They're going to transfer it over to the NASA Glenn Research Center. But it's kind of troubling because these generators were supposed to take use of what very little plutonium NASA has right now. They're about 4 times as radio efficient as the MMRTGs that NASA is currently using, like on MSL and New Horizons and Cassini and all these spacecraft that are out in the outer solar system. They basically need RTGs to operate because you can't use solar power out there. Juno will be the first spacecraft to go to Jupiter and use solar power, but it needs these gigantic solar panels to do it out there. And even then, they have all kinds of constraints with Juno, like it can't get too close to the Io Jupiter flux tubes right now because of the radiation, and they have to be on a far out orbit, and any kind of micrometeoroids could end that mission out there, any kind of dust or debris. So it's kind of troubling. There was a plutonium shortage. The government and DOD stopped making plutonium in 1989, and we were running up against a shortage until this year when they restarted production, and eventually when they get ramped up, the production process is kind of slow. They're looking at making 1 to 1.5 kilograms of plutonium per year eventually once they get the whole process ramped up. But say a spacecraft like New Horizons uses 11 kilograms of plutonium for its MMRTG. That means that with these current RTGs that we're using in the production rates, that we're probably going to see, if you read the writing on the wall with the current productions and going with the old technology, we're going to see 1 to 2 outer solar system missions per decade. We've kind of been keeping at that pace right now. If you think about MSL was RTG powered, that went off 2 years ago. New Horizons went off 2006, that was RTG powered. Cassini before that in 1999. But they were going to make these ASRGs in order to take advantage of. You could have more of these small Discovery class missions. You could have 4 Discovery class missions for the amount of plutonium it would take to do one big Battlestar Galactica type mission out there, one big Cassini type mission. So it's unfortunate. They're still going to do the research and development on this, but the 2 ASRGs they were going to make for 2016, those are shelved right now. So it's kind of troubling, and it's kind of unclear how much research and development they're going to do at the Glenn Research Center with this. I was talking to Casey Dreyer at Planetary Society when I wrote this article, and it's part of that whole grim story of basically NASA doesn't have the money to do as much as NASA would like to do right now.
This is really troubling. These RTGs are just the best way to power these missions.
Yeah,
you can see what's
Voyager
happening.
2 is still going.
Yeah, Voyager 2 is still going. The Pioneers are still. I don't know if they're still going.
No, the Pioneers are silent.
Cassini,
Yeah.
Curiosity, and Curiosity is a great example. I mean, we look at the power problems that Spirit and Opportunity have had. Curiosity is not going to have any of these power problems. It's got tons of power, and it has nothing holding it back, and it's going to go for, hopefully for years and years and years.
The half-life of plutonium is right around where you get half the amount of energy out of it from radioactive decay is in about 70 years. So we could have Curiosity could keep going for a couple decades.
Yeah, and you've got New Horizons, which
that could go for 50 years too.
Which is going to just be able to go past icy object. After it finishes its flyby of Pluto, you can imagine it going after icy object and just making all kinds of amazing discoveries. And the fact that they're running out of this plutonium for these RTGs is a really big problem, and it's too bad because it sort of shuts down and really compromises a whole class of type of exploration that is very good. And Go ahead.
Something I learned from the MSL tweet up when I went for the launch is that I didn't know is the plutonium for MSL came from the Russians. They actually bought that off the Russians. And there are some other sources out there that they're trying to procure some more plutonium from various places. I always thought it was kind of interesting, and I don't know. I think they would have to reblend it from when I was talking to somebody at Sandia Laboratory. There are a few accidents that they've had over the years with RTGs that they could possibly go after. There's an RTG at the bottom of the Marianas Trench from Apollo 13. They don't tell you that in the movie. It was supposed to be at one of the ALSEP experiments on the moon when they jettisoned the Aquarius LEM and put it into the Pacific Ocean. It had a nuclear RTG on board. That was one of the reasons they put it in the deepest part of the ocean they could think of. But it's never. They've done searches for it and they've never been able to find it. There's never been any radioactive contamination that they've detected. But I always wondered if they could go after that and repurpose it again.
Yeah, that would be an interesting mission, wouldn't it? Here, I've got one little thing here. Richard Drum. Our good friend Richard Drum did get a copy, a video of the launch of, was this the Laddie launch? A Minotaur launch.
Oh, cool.
Yeah, so that's just sort of what a Minotaur launch looks like.
Wow.
Yeah, a lot of people saw it. It was a good night launch right up the East Coast.
Yeah, that was the Laddie launch, so he was noting that we could use that.
Oh, one minor thing I wanted to say about the ASRGs, they were saying that there may be some more clarification coming out of the American Geophysical Union fall meeting here in a few weeks, so I expect I'll probably be writing about this again in December.
Now, there are sort of larger NASA budget problems, and Nancy, you have some information on this?
I do.
Did I segue too fast there? We were talking about...
I know they were talking about possibly pulling the plug on Cassini next year, as Elizabeth Howell wrote about that on Universe Today. But.
Yeah, Elizabeth wrote about that, and so...
What do you have on that, David?
Well, I know it'd be kind of sad if they... I kind of read that and linked to it in conjunction to the ASRG article about them stopping that production of those units because Cassini is plutonium-powered as well. And they're talking about they may not have enough money to keep tracking and operating all these missions. Cassini was scheduled to end in 2017. They're going to deorbit it, kind of like they did with Galileo, where they deorbited it into Jupiter.
Yeah.
They were going to deorbit Cassini into Saturn. And that was one mission I know they had talked about. That it's among others, she was mentioning that they may have to stop monitoring and tracking, which is kind of a shame because it took us several years to get Cassini out there. Over a decade, if you count from research and development to getting it to the launch pad. It's the only spacecraft that's ever orbited Saturn. It's turning out all these awesome images, and you never know when something happens, like Comet Shoemaker Levy 9 that hit Jupiter. It was cool that we had some eyeballs out there to look at. You never know when something surreptitious like that's going to happen, and it's handy to have eyeballs at different areas in the solar system to watch these things. So.
And last week we talked all about the big photo that Cassini had taken of Earth, and everyone was included in that image. And I think the Cassini's done a really good job. The Cassini team, Carolyn Porco, and the rest of the Cyclops team has done a really good job of keeping Cassini in everyone's mind and making sure that we're all aware of it. And I think that's gonna really help it out if that decision comes down. It's the same thing as the Hubble Space Telescope. I mean, people have threatened to cancel the Hubble Space Telescope in the past, but boy, look at those pictures. How could you? It's like, I don't know. It's like
there was some
kicking
talk
a puppy,
There was some talk in the article about cuts for manned space flight and cuts for what they're doing with the ISS right now. And I know the Russians had said before if we don't want the ISS, they would take it over. Which would be kind of strange, but.
Yeah. Elizabeth wrote that it was from the Congressional Budget Office that looks at kind of all the possibilities for spending, and one of their proposals was to cut the human spaceflight program. But I guess this is something that they bring up occasionally, so it's nothing new. And then, like you mentioned, David, right now NASA's they've got 4 potential commercial crew transportation companies, and a press release that they put out earlier this week indicated that they would consider having more than one, perhaps 2 or 3, and then one idea from this proposal put out by the Congressional Budget Office was just to have only one commercial crew partner. So That's disappointing. I think the having multiple commercial crew would really be great. As far as having better possibilities of what's going to happen.
Competition, they always think competition is supposed to drive free market. So,
right.
I got to say, when I visited the SpaceX facility a couple of weeks ago, and you see the stuff that they're working on, and the gimbal motors and the innovation that's happening, even if there's problems with the budget in this short term and a lot of missions, these are really holdovers from older budgets and older methods and international cooperation and so on. But there's a whole new generation of aerospace firms and launch methods and providers and stuff that I think is gonna keep the system going. So I wouldn't see these kind of budget crises as any indication of what the future of spaceflight is going to look like. If anything, it's brighter than ever. Well, you know what? Speaking of new space, Amy, let's. You reported on Inspiration Mars, looking for help.
Yes. Maybe not the horse to bet on if you want to go to Mars. So Inspiration Mars, just for anybody who doesn't know or doesn't remember which one it is, because I always get it mixed up with Mars One in my head as crazy Mars things. Inspiration Mars is Dennis Tito's initiative. The idea is to send a married couple on a free return trajectory flyby of Mars. It would be a 501-day mission, and the ideal launch date, I think it's like December 27th, 2017 to January 5th, 2018, which gives you the shortest transit time. And he really wants to do this, and in the press conference I think it was in February, I remember watching it, everybody was very, really like harping on the inspiration bit and talking about how this is a mission for America and how it's going to, reinvigorate everyone into space exploration, and it's going to happen because Dennis Tito, having millions upon millions of dollars, it has funded the first 2 years of the program. So what that actually is he said that he would give about $300 million of his own money to the program, but the mission is going to cost, their estimate is about $1 billion. So that other $700 million turns out it's not as easy to get from crowdfunding or private investors or corporate sponsorship for, I'm not sure what the return it would be on that, but so he's asked at a House committee meeting. I never remember what the House government stuff is here in America. He publicly has asked NASA to take the reins of this mission and basically give him the extra $700 million that he needs. And the issue behind all this is that the mission that he designed was supposed to be basically like, you launch to Mars and you let Newton do the driving, and basically, physics takes care of it. But turns out that the mission can't be that simple. It's a lot more complicated, and he needs the technology that NASA's developing. The SLS has an upper stage that would be needed to launch a spacecraft that heavy to keep 2 people alive for 501 days with all the emergencies and everything. He needs that to launch a spacecraft that heavy to Mars. He needs some of the technology that they're developing for Orion, which is built with long-duration mission and very fast re-entry, surviving very fast re-entries. He needs that technology. So the sort of thing is, hey NASA, I need your technology, so you fund the mission, and any technology you develop in getting my mission off the ground, you get to keep. So yeah, we've just talked about how much NASA has no money right now, and that's, $700 million is a lot of money, and that is not extra money that NASA has just kicking around. And I think the real issue with this is that 2018 is not that far away, and if you get sub-program off the ground, it's going to be a crash program, and crash programs generally don't develop really solid long-term technology that you can apply to greater things. This is, and they keep talking about how Apollo 8 was so inspirational because it went around the moon. Well, Apollo was a crash program, and it didn't leave us with technology that was broadly applicable to other missions. So let's look at history and not repeat that. Doing that mission again for, scientific return that you could get with an unmanned mission for inspiration's sake doesn't seem like something that NASA would sort of shelve everything else to do. It doesn't. I don't think there's a reason to do. I'm a firm believer in taking very measured steps to these things to develop technology that can go to multiple programs, be they manned, unmanned, Mars, Venus, whatever, wherever you want to go visit with whatever.
Why do you hate sending people to Mars, Amy?
I don't hate sending people to Mars. I don't like crash programs.
All right.
They don't end well. It's just gonna, yeah.
Just look at the name.
I know.
But I mean,
hopefully not
this
ending in a
mission.
crash,
But I mean, this mission was sort of like the Apollo 8 mission, right? That you send the astronauts, they go around the moon, and they would return, and look at the moon with their own eyeballs, I guess. And in this case, it would be Mars, right? They do a flyby of Mars. They would look out the window, go, "Yup, that's Mars," and then they would come home.
I think my issue with that analogy is that Apollo 8 wasn't launched because it was let's keep everyone inspired as we go to the moon. It was, okay, we don't have a lunar module that can fly yet, and we have this Block 2 Apollo command module that we know is flight-worthy, and we don't know a lot about the lunar environment, and we need to test the main SPS, the Service Propulsion System engine, so let's not waste time. Let's do this and cross all of these steps off of our list in going to the moon. So it was, I mean, Apollo is a crash program, but it was a very structured crash program. This Inspiration Mars, as it's designed, unless there's been some change that I haven't seen yet, is not taking a step towards another goal.
I mean, it's been.
And that's why I don't like that analogy. It's sort of taking the good thing, like the sort of, the Earthrise wonder of Apollo 8 that we remember, and taking it out of the context of everything else that it was a part of. There's my rant.
Okay.
I went and asked my wife, and she said no. So.
No, you can't go. All right.
No, it was she would, which is too bad because we backpacked around the world together. So I thought, we would probably be able to put up with each other for a 500+ day mission. So.
Right.
But.
Yeah, I mean, I think building on what Amy's saying, and I had a rant about this on my video channel, which is that I really think the most sustainable long-term way to do this human space exploration is to just keep setting the bar higher and higher and higher, one incremental step at a time. Build a good technology platform, and then send up why we've done an orbit of the moon, but we haven't done an orbit of an asteroid. So that would probably be easier than going all the way to Mars. Let's do a return mission around an asteroid. Let's do a return mission to a Lagrange point. Let's just keep building the capabilities. Now let's send 3 people. Now let's send 5 people. Now let's and just keep that whole process going, step after step after step.
Well, it's 2014 here in a few weeks, so his window of having something on the pad is kind of closing in a year or two, really.
Yeah,
and
he's got the secondary launch window in I think 2021. I can't remember what the dates are, but it would be an 89-day longer mission, but still could work. So he's kind of gunning for that as his second choice. But
if they do it, they'll break the human spaceflight endurance record easily. I think by 100 days if they do it.
Yeah. So I'm all for an orbital mission. I think what would be really cool would be to have a crew in orbit around Mars controlling a rover in real time. I mean,
there you go.
That would be really cool, and then we could do that. While we keep working on figuring out how to land a big enough payload. But whipping around the far side is sort of like going a really long way for not a lot.
The only science you'll get is just the human physiology aspect of what does a flight to Mars do to people after.
No, you'll get a ton of stuff, right? You're going to get the human physiology. You're going to be like radiation shielding. You're going to be working out. You won't be handling is entry and landing.
Yeah.
But you're going to get every other part of the mission about just, as you said, the human physiology stuff. How do you keep these people alive? What kinds of flight trajectories are appropriate? Yeah. It's worth doing, and it probably will be the first mission. Will probably be a flyby, probably a human flyby, or maybe just a cheese flyby, like what they did with the Dragon capsule, what SpaceX did with the Dragon capsule.
Yep. You almost think that
flyby.
Oh
yeah. The first when the Dragon capsule went up, they put a human being's worth of cheese. Big block of cheese into the spacecraft.
I think
took that to orbit.
I think it would be tantalizing to see Mars in the window and not being able to stop. It's like there it goes. It's
we're gonna get that with New Horizons when New Horizons get past Pluto.
Yeah, it's just gonna whiz by.
Yep, there it is. Bye.
Yeah.
Oh. Okay, so let's talk about some problems that Curiosity is having. Nancy.
Yeah, recently the Curiosity team reported that there was what they called a soft short on the Curiosity rover. A hard short would be something like two wires coming in contact with each other and really kind of being a mission-ending thing, but soft short was just kind of a reduction in the amount of electricity that's available. So, and actually, right, Curiosity did not go like into safe mode or anything like that. It was just something that they noticed in the data that they get back from the rover, and so there's a reduction in the amount of power that's available. But they're doing some troubleshooting, and the rover is actually still working, but at a reduced pace. And there was no reboot or anything, but I think they're looking at it. This has happened before. It happened right after Curiosity landed, where there was this kind of drop in power, and they thought that was from the kind of the explosive bolts where it came down off of the hover lander thing, and then I think they actually had this happen before since then. But this one I think they're a little more concerned about because it's kind of a repetitive thing, and so they want to look into it and make sure that they understand what's going on. So that would be something to keep an eye on because a hard short would not be good.
Yeah, all this talk about this wonderful RTG generator on the Curiosity, and if it gets a hard short,
don't this week.
Yeah.
It's got two. It's got two RTGs on it, so.
So if one goes, yeah.
Got a backup.
Okay, so and then I think the last story we got this week, Nancy, is that there's a high energy jet coming from our black hole.
Yeah, we've really not seen that before, and while the kind of the common idea of black holes is that they suck and kind of vacuum up everything in the vicinity with that stuff never to be seen again, that's not always true because there's it'll kind of a lot of black holes will kind of burp out for some reason stuff that it doesn't want in the form of high energy jets, and astronomers have seen jets like this around lots of supermassive black holes, but in other galaxies, not really from ours. They've seen kind of indications that maybe there was one at one time. They called it a ghost of a past jet. Maybe they were thinking that they saw it. But now they have kind of what they're calling their best evidence that the Sagittarius A star does have a jet, and it's only one. A lot of times these things come in pairs. But they didn't actually see the jet itself, but with the Chandra X-ray Observatory, they actually saw some X-rays. It appears like the jet is shooting into some gas, and so they could see some X-rays coming off from that gas, and it kind of was pointing back to the black hole. And they also looked at it with the Very Large Array, and there was some radio emissions that also kind of indicated the same type of jet. And it was pointing back to the supermassive black hole. So kind of exciting. It's really very faint, so it's not something that's easily seen, easily detected, but they were pretty excited. I mean, Chandra's been looking at for this since 1999, so I think they were pretty excited that they actually saw something.
And I think it's important to understand before people ask us this question, which is I thought nothing can come out of a black hole, that these jets are emanating from the environment around the black hole. So, all this material tries to fall into the black hole, it gets caught up around, swirling around the black hole, and it gets very hot and a very complicated magnetic environment, and that can form these jets to pour out of the supermassive black hole. They're not actually coming from the black hole. Once you cross that event horizon, that matter is done for. But just outside the environment of the black hole, you can get these jets that will pour out. So,
right.
Cool. And that's like one of the most, some future civilization that could be the most efficient method of gaining energy. Is you just feed a black hole, you let this energy get swirled up around it and give off mountains of high energy gamma radiation, and then you just scoop it up and enjoy energy future. Okay, so I think we're just about wrapped up. There's one giveaway that we're doing this week, Nancy, and I think there's still a couple of days left, so people still have some time, right?
Right. Yeah, we've got the brand new 2014 calendar, and I actually hang on a sec. Yeah.
I haven't got one yet, and Jason had one last week. So I don't know if you guys gotten one. Nancy, no. Nancy's got one. David, have you seen this thing? Yeah. Okay, there we go.
Yeah.
That's awesome.
Nice.
Yep, it's really cool, and it's a huge calendar. It's got all these great pictures, different stuff every month. There's biographies about different astronomers and people in space, and it's just great. I love having it on my wall because I can, there's something new every month, and there's all sorts of info, and of course there's room to write your own info. So it's a great calendar. So we have a giveaway on Universe Today, 5 of them, and we'll probably have some more of these later. So feel free to keep tabs. We'll have some more giveaways as well. Then.
So that's proof, Nancy, that Comet Ison isn't going to wipe us out in 2013. That the 2014 calendars are coming out.
Exactly.
Done, yeah. And so the giveaway goes
through Monday.
To the 25th. Yeah. So you've got until the 25th. So you come back to Universe Today, and there's a link to that article, and you can go and just put in your email address and do a giveaway. And you might be amazed, but that was not an advertisement. So we actually don't charge them any money for doing these giveaways on Universe Today. We're trying to get a lot of giveaways, like space-related giveaways on Universe Today, and we pretty much give away something every week almost. So this week we've got this, and we've put his feet to the fire. This is the Year in Space, and I think he's going to do a few more versions of this giveaway further along into the end of the year. So it's a great opportunity to win a copy, and if you want, they're not that expensive either, like $12, I think. Yeah,
yep, they're great. There it is.
Yeah, buy the calendar for $12.95. So there you go. Yeah, they're awesome.
We've been talking about MSL, Fraser. I just put up an image real quick. I came across this in my research, and I had actually never seen this picture before, of MSL upside down in the laboratory with its RTGs installed there. Those fin-shaped things on the very back of it there. So I had never seen that picture before, so I was like, that's kind of cool.
Amy, you were at NASA JPL a year and a half ago, and did you get a chance to see that full-size model of Curiosity?
I have beside it? Picture of me not next to it because there was a velvet rope that you couldn't go beyond. But it was out there, and what was great was they had that, and they had Spirit Opportunity, they had the Phoenix Lander, and Sojourner, which is my favorite because it's tiny. So you get to It's great to see all these things full scale. That thing's massive.
Yeah, it is really something to stand next to the Curiosity rover and realize just how intimidating a machine it really is.
That's what I heard everybody say. They said it's much bigger than they expected.
Yeah, when they say SUV size, they mean that.
Yeah.
I'm jealous. I never got to see it in person. When I saw it, was inside its fairing already. So.
Well, there's this full-scale model at JPL, so now you've got an excuse to go to NASA JPL.
Cool.
There's one at Arizona State University for anybody who happens to live in Phoenix. Don't know why they have one, but yes, I have. But I did get to see the full-scale model at ASU. It was, again, walking by it. It's just like in a lit window in the physics building or something. It's just sort of walking by. You're like, wow, that's a big rover.
So just a couple of quick comments and questions from the audience. Alexander Howlett says, what could possibly be more inspirational than watching a married couple get a space divorce?
I think in the press conference, actually, I should have said this earlier because it's funny that they talked about they would have someone like Dr. Drew on hand for marital counseling when things got rough.
Yeah. So that would definitely increase the publicity if things went south in the marriage and they're stuck with each other for another 500 days.
That's the real human factors gain is how people react when crammed in a tiny environment with their spouse.
Another good psychology experiment.
Yes.
Yeah. Hugo Burnham says, as Nicole Gallucci isn't here, I'll say it, black holes do not suck. So.
That's right.
Thank you.
Yov Landsman says, Apollo 8 wasn't supposed to go around the moon. They changed their plan to answer the Soviet Zond 5 mission that orbited around the moon with a cargo of animals.
Yep.
Sort of.
Sort of?
It was spurred on slightly because, Zond 5 went, I think it was in August, and they had turtles and stuff around the moon, but the idea of maybe taking Apollo 8 into orbit was already on the books at NASA. It may have been sort of nudged a little bit by the Soviets, but it was more because of the state of the Apollo program. But yeah, there was a bit of a factor in there. Space turtles.
Space turtles. Okay, so why don't we wrap this up then? We've sort of reached our hour. Amy, Shira, Teitel, where do we find out more from you?
Twitter as AST Vintage Space, Google Plus and Facebook as my name, and my blog is at Popular Science Vintage Space. And others, but just try those.
Vice, Motherboard. Do I have to say this all for you? Okay.
Scientific American stuff.
Scientific American,
places.
Ars Technica. Okay. David Dickinson, where do we find out more?
See, I've been active this week on Universe Today, Listosaur, Canada.com. I've been kind of lazy this week as the launch took up the first half of my week traveling to that. So.
Oh, did you see a rocket launch? Did it make you tired?
In person. Oh, yeah.
Aww.
And let's see, what else? Oh, I'll probably be at the Virtual Star Party Sunday night, although I don't know if I'll have anything to... I think Jupiter's in range now, so I may be able to start bringing that.
Fantastic. And no stupid moon, so that'll be good.
No.
Nancy Atkinson.
Hate on the moon.
We hate the moon. Nancy Atkinson, where do we find out more?
Universe Today, you can find me there almost every day, and I'm active on Twitter at Nancy_A and Google Plus and sometimes Facebook.
Fantastic. All right, and of course you can see some of my stuff on Universe Today. I'm doing lots of cool videos on YouTube. We're going to be releasing, hopefully, all of the interviews that we did down when we were in Los Angeles last week. So we've got a whole pile of really great interviews that are going to be coming out over the next couple of weeks. So stay tuned for that. And the next big thing we're going to do is the Virtual Star Party on Sunday night, probably 6 o'clock Pacific time now. So we can definitely go earlier and earlier now. So
Yay,
push it to 5. Yeah, I think we'll push it to 5:30 next week or even 5. So cool. All right, well, thanks everyone for watching. Thanks to the team for joining me this week. I really appreciate it. And we'll see all of you next week.
Later.
Bye.
What? Why doesn't it work? There it is. How will I know who I am if I don't have that there? Okay. Well, hi, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, November 22nd, 2013. Joining me this week, we've got Amy Shira Teitel from Vintage Space. Hey, Amy.
Hello.
We've got David Dickinson, a.k.a. the
Hey.
Astro Guys, the cloudy astronomer. Oh, we're going to get into that in a second.
Yes.
Uh, and Nancy Atkinson from Universe Today.
Hi, everybody.
Hey, Nancy. So this week, let me bring this list over here. We've got 5 active comets visible with binoculars in the night sky, actually the morning sky. Halting nuclear engines. We've got a zillion launches, and I mean that specifically. 1 zillion satellites have just been launched. We've got Inspiration Mars update. High-energy jet from the black hole, 15 years of the International Space Station, possible NASA cuts, and problem of curiosity. So let's get rolling. I think let's start specifically with all of those launches. The biggest one here is MAVEN. So Amy, why don't you talk about the MAVEN launch, and then I know David has a whole bunch more as well.
Yeah, well, I'm sure. I mean, David and I were both at LASP in Boulder, Colorado this summer at the meeting all the science teams. So, David, feel free to jump in because.
Were you at the launch this week, Amy?
No, I couldn't get down. Knowing the uncertainty of launch windows, I couldn't.
There were thousands of people there, so
Really?
we would have never run. I didn't see anybody from LASP there.
Really? I knew a couple people were going down, but no, I watched it. I remembered about 5 minutes before launch that it was happening, so I did get to NASA TV to watch it. And for a mission that has no visuals, they did a really great job of having sort of a sort of animation of what was happening during the whole launch phase. And it was, from what I heard, I don't know if anything has come up after, but it was a flawless launch. Everything seemed to happen pretty much on time. They started right at the opening of the launch window, which means that they are on track to get to Mars. I think September 22nd, 2014 is the estimated date that they're going to go into orbit. And it's a really cool mission, and I don't just say that because I spent time with part of the science team and think they're awesome. MAVEN is basically going to look at Mars's atmosphere and sort of reverse engineer what happened to the planet, why it sort of became this cold, dry, more or less atmosphereless world that we see. So I think my favorite analogy for this, oh there, we've got Fraser showing the launch here. My favorite analogy of what MAVEN is going to do is that if Mars is a pot of boiling water, MAVEN is effectively going to scoop up a little bit of the steam and try to figure out how much water was in the pot before it was boiling. That's
Yeah.
kind of neat.
We had a low deck cloud deck as seen from the causeway, so unfortunately we saw the launch for about 20 seconds before it vanished into the clouds, but it was still kind of cool to see. Yeah.
Yeah.
It's one of those launches like there it is, oh, it's gone.
Well, popped off the launch pad pretty quickly.
Yeah.
I don't know.
Yeah, it did.
I'm sort of used to watching old Saturn V launches, so anything that's smaller than that just seems to just rocket right up, quite literally rocket right up. But
what's the launch vehicle?
It was Atlas V.
It was an Atlas V.
Yeah.
But with no external boosters, it's just a straight up.
No, it went a
That's
401 configuration. Yeah.
I actually thought it took a long time to get going, but that's kind of an Atlas V thing. I mean, I remember I was at the SDO launch and same thing. It just like, okay, are you going? You going? Yep,